Hello everybody, welcome back. My name's Jace. This channel is about my efforts to make an N-gauge railway, and thank you to all of the new subscribers. We're over 100 subscribers. In fact, thank you to all subscribers, not just the new ones. Incredible. The channel's only been up, what, a few weeks, and yeah, compared to some other YouTube channels I've done in the past, it seems to be growing quicker than the others did. So maybe that's just a bit of experience, and I don't know. Maybe it's my subtle, charming presenting style. Either way, thank you very much. Now, for those of you that have been following the channel for a while, you may notice some difference on the track. I've tweaked it slightly, and what I've done is I've removed a point that was here that then split the good siding into two tracks. And the reason I've done that is I just felt it was too cramped. The goods yard area was going to be too cramped with two tracks in it. So by removing the point and making it a single track, I've ended up with about the same space for wagons anyway, because that one siding is now longer, about the same length as the other two combined. And I've been playing around with the little base from the Dapol goods shed, just offering it up and seeing where things could go. And I've got an order, a little N-gauge lorry from about the 1950s era, to sort of see how that's going to work in this area, in relation to the tracks, the goods shed, and the access that I mentioned in the previous video, whether it's a tunnel, a bridge, or a crossing of some sort. So that's all stuff to come in the future. The other thing that is off camera at the moment, but I've put the electrics onto one lead. So all I have to do is plug one lead from this board into the mains, and I'll show you how I've done that. But before I show you underneath, I'll just show you the track. Good siding that is now a single track. This is where the point was. And so, as you can see, the sidings used to be a point here and then split into two, and now it's one. So I've got roughly the same amount of wagon space. So yeah, we'll see how that goes. And then this is now the one cable that I have to plug in to the board. So I'm going to flip the board now and I'll show you. So underneath now, I have 230 volts coming in, down to this. I've got my NCE transformer here, all nice tucked up out the way, so I don't have to keep plugging this in and feeding cables through a hole in the board. And then I have this, which is a 12 volt transformer DC, and I've wired it up to there for now, to that buzz bar. So I've got live and negative, blue and yellow, and that terminal block is probably going to move, but just for now, that's how I've done it. So this video is about the control panel, which I'm going to mount somewhere here, or at least temporary mount it there. And I'll flip the board back and I'll show you the plan that I've come up with. That's my plan. I've done this in PowerPoint basically. I'm sure you could do it in Word or a similar thing. And this is an actual size sort of control panel. The orange circles, the orange dots are switches, and that's the silver washer size. So it's not the toggle itself, it's the size of the silver washer. And the green dots are obviously LEDs, which, if I wire it up correctly, should light up as points and things are changed to show a route. And then this area here is all to do with the turntable. So in the middle there will be a potentiometer to increase the speed, and we'll have a switch here to reverse the polarity to the motor so that I can go anti-clockwise or clockwise. Regarding the bridge, obviously as that rotates 180 degrees, I do need to switch the polarity of that as well. Now I've put a switch in here for that. I may not do that. I may put a little juicer under the board to save all the hassle, because from prior experience of layouts and having reversing loops and things, trying to remember which way the switch is in relation to the polarity of track can get difficult, and you end up with short circuits because you forget to switch it. And also it's going to be even more difficult to keep track of it with a piece of track that is actually rotating 360 degrees. I could put an indicator on the bridge each end and mark that on here, you know, maybe a pigeon sat on a railing or something at the one end. But the point is, if I wire this in, it's something that I've got to operate and remember, and if I put a juicer in, I can forget about it and just play trains. So that's that. Over here I've got a little lighting section, and I thought, well, I could split the layout into sections and do the lights accordingly. And advantages for that would be maybe when I make some videos of it done operating, and also I can sort of wire one section back to a switch, have it working, and not have to break into it again to do another section. So, and for fault finding as well, it'll be quite easy. I can isolate sections. Now, you'll notice that the points are numbered. So the first point on the whole layout is P100. P standing for point. But when I come to run wires, I will be labeling them. And rather than confuse it with numbers and letters, what I'm going to do is, so if the number starts with a 1, it's a point related wire. And I know that throughout the whole layout then. Maybe I will do lights starting with a 3, I don't know. But yeah, so point 100, point 101, point 103, point 104, etc. Now the double slips, obviously I've drawn them and will operate them as 2 points, because you've got two point arms and 2 sets of switches, you know. So that's those, and as you can see, so that and that there is that and that, and that and that is that and that. And the 3-way point as well down here will have 2 motors, 2 switches. So, and then at the bottom I've just labelled what siding is what. So that's actual size. I'm going to, in a bit, we're going to get a piece of plywood or something, stick that to it, and then I know where I'm going to drill my holes to mount the switches and LEDs. Now when it comes to wiring, I do like things to be tidy, traceable, things like that. So I've actually done myself a wiring diagram based on the diagram from DC Concepts with the points. And I will be following, there's 3 diagrams in the booklet that comes with it, with the point motors, but I will be following this one. So I've kind of done myself a wiring diagram for my layout based on this drawing. And here it is. So as you can see, the point wiring along the bottom there in the boxes, we've got the point numbers, so P100, 101, 102, etc. They're connected to terminals 1 and 2 of the point motor to the DC bus wires, so DCC red and DCC black. Out of terminals 3, 7, 8 and 9 of the point motors, we have wires. Number 3 goes to an LED via a resistor. Number 7 is a switch wire, number 8 is a switch wire, and number 9 is a switch wire. And you can see that I've numbered the wires in the terminal block, roughly in the middle of the drawing. So if it was point 100, and we're looking at the brown wire coming out of terminal 3, that wire's number is going to be 1003 or 103. Similarly, if we look at point 101 at terminal 9, that's a red wire, and that wire's number is 1019. So it's the wire number is the number of the point motor it's operating, and the terminal number of that point motor on the end of it. And the beauty of that is, if I am walking about, drop the board, getting it in the loft, or I rip a wire off, I can easily trace that wire. I've got a wiring diagram, and just by looking at it, hang on, it starts with a 1. Right, now I know it's point related. And it's got a number 7 on the end. That means it goes in that point motor's number, terminal 7. That's what I'm trying to achieve. It is more work, but in the long run, it could save me hours and hours and hours and hours of fault finding. Now I should also mention that points 103, 104, 105, 106, 109 and 110 are the double slips and three-way point, and therefore I need to power the frogs on those points as well via the point motor, and they share terminal 3. Now I'm not going to give the frog wires a number on this drawing because it's fairly obvious just by the length of the wire from the point motor to go and disappearing through the baseboard that that's a frog wire. So the frogs on certain points will be sharing the LED wire line terminal on the point motors as per the DCC concept drawing. Now, if anybody sees anything wrong with that wiring diagram, please let me know. Obviously, I'm not an expert at this. I'm trying to do things in a sensible way that's going to help me now and later, and keep things tidy and etc. But if I've made a mistake on that wiring diagram, please let me know. You'll also note on there that the LEDs run through a resistor. So I will be building a little board with resistors on, but I've never done before, but that's going to be coming up in a video, probably not this one, but in a video. So I've been collecting items to use on this control panel. So I've got a potentiometer here with a little circuit board. So that's for the turntable. 12-volt LEDs, green of course, with the holders. I think there's 50 pieces here, and I think it was about £7, pre-wired with a diode. And I thought, I was going to save me so much work, cutting all the tails, soldering in all the diodes, etc. And I thought, right, I'm going to go with that. So there's 50 there. I think I've got 26 on the board. So that means I can screw up nearly 50% of the time and still have enough. I've also bought, well not bought, but I've had the switches. So these are the switches for the point motors. Here's one I've used before. So these are momentary switches. So you click it across, but as soon as you let go, it returns to neutral. And obviously both ways. That's how I'm going to power or operate the point motors. I like the idea of having a switch rather than a button. Don't know why, that's just personal preference. And I know that you can use these type of switches because I saw DCC Concepts doing it at the show last weekend. And then I've bought your normal sort of switches for the lights. So these are just on, off, on, off, on, off. What else? What else? I'm sure there's other things that I need to tell you, but I think what we need to do now is get a piece of plywood cut to spray and then stick that onto. I know that this isn't going to last, you know, it's paper, it's just literally home printed photocopy of paper, but it just gives me a plan and it gives me somewhere to mark the holes and drill. And I thought about, well, I could screw a piece of perspex on the top of that, but why? This might change yet, and you know, I might want to alter it in some way. So I'm going to do it like this, and then once I've got the design exactly how I'd like it, then I can print it off again, put the switches in it, and put a piece of perspex on. So that's the plan. That's my piece of wood cut. I think it's a piece of 6mm ply. I've just run that off on the little table saw down the shed, and that's got to get fixed on there. So what I'm going to do, I've folded it to the size I want. I'm going to leave those on, I'm not going to cut them off, and then I'm going to try and wrap them round and glue them on the back as well. Might give it a little bit more chance of surviving for a while. So, piece of wood, and I'm going to use a spray adhesive for this. I just think if I go with PVA, this is going to get too wet and maybe disintegrate before I even start. So I thought I'll give this a go. Who knows, I've not done this before, but you know, I can print as many of these off as I want. So the secret is not to stick it to that as well. I've got a little bit of time to play about with it. Yeah, if I still move it, that's good. Right, get that out of the way. I'm going to spray this off the worktop. And then fold those over. Okay, so I'm going to let that set for a bit, and then we need to start drilling out some holes, or at least trying to. I'm hoping that that glue is going to hold the paper enough that it doesn't tear out and destroy the drawing, but we'll see. and I'll obviously have to take it nice and steady as I drill. So I think I'm going to start with a 3mm. And try and hit the centre of the holes. Wasn't too bad. Now this one I'm going to do this one I'm going to leave for now because I think I'm going to go down the juicer route for the bridge polarity. I'm going to get these drilled out to 3mm and then we'll step it up. Okay, that's everything drilled out to 3mm with no disasters just yet. I'm going to do the LEDs next. So let's just open this packet. I think what we need to do on these is just tidy them up with a countersunk. That's better. I'm quite pleased with that as a first attempt, as a temporary job. Switches work. Turned out you need a 7mm drill bit for the LEDs, the LED holders and the switches. So nice and easy. Could go through with say a 4 first and then a 7 and just drill all the holes. I've still got some switches to put in, but for now I'm just going to focus on the points and the LEDs. And then on the back you can see that there's plenty of room still for wires. I'll obviously take the switches out and wire and solder the wires to them and put the switch back in. But the whole point of this is to keep everything tidy and in a place rather than temporary wiring up points and having wires everywhere with switches on the end, and it brings it all back. I've got somewhere to wire to. So I'm pretty pleased with that. It is going to get all grubby and what have you, obviously. I am already thinking I need to expand it a little bit so that the distance between switches is a little bit bigger. Not much, say another 10mm, something like that, just to give a bit more of a space between the switch and the LED, because you can't really see the track there and there and there and there. It's a switch, a light and a switch. So, but that's the whole point of this prototype board, is to test it and see how it goes. I've obviously yet got to fit the point motors so that I can wire to this end and the other end. And if I turn the camera, I've got to wire everything to a terminal block. So I'm going to, all point motors are over here obviously, and they're going to come across to a terminal block or a series of terminal blocks here, and then from there to the control panel. And the idea is that I can unplug this terminal block and put the control panel on either side of the board. And if I keep the control panel flat like this, not at an angle, it doesn't matter which side of the board it goes, because these points are all in the same orientation. whether I'm on this side of the board or that side of the board. Admittedly, the right in will be the upside down. 44 point wire cables, DC power, DCC power, and motor wires for the turntable. So around 50 cables in total, and then that's without lights. So once the lights go in, I'm going to have a live into and out of these switches. That's another 12 wires, and then they could all share, all the lighting circuits could share a common DC negative bus wire underneath. So a lot to go at, but happy so far. Right, thank you very much for watching part 1 of this control panel build. I don't know how many videos are going to be in this series. Haven't really got a plan for that. I'm just going to video what I'm doing and show you guys, and hopefully you can give me some advice back. Maybe I can teach you a few things. That's what it's all about, the YouTube community. So thanks very much for watching. If you've enjoyed the video, please give it a thumbs up, and if you want to see how this progresses and all the wiring problems that I run into, then hit the subscribe button, hit the bell icon and click all, and then you will be notified when I upload another video. Thanks very much. See you next time.